Hello, welcome to this OCR Further Maths Statistics video, the fifth in the series looking at chi-square tests, and this time looking at goodness of fit. You should already know how to work with a contingency table to create a chi-squared test statistic to test for association. We can use the same method for testing whether or not data fits a particular model. In this data, we'll look at a distribution defined by a ratio, but we can also test for standard probability models. Here we have some traffic data, together with a hypothesis. As usual, we start with our null and alternative hypotheses, and our significance level. Let's see what the data would look like if it did fit the ratio exactly. The total number of vehicles is 120. The sum of the ratio portions is 12, so divide 120 by 12 to get 10 vehicles per ratio portion. So that's 10 for the bus, 20 for the lorry, 30 for the van, and so on. We can compare the two sets of frequencies informally using a graph, but the chi-squared test will give us a measure of how similar they are. We calculate the degrees of freedom. Here we have 5 classes, and knowing the total frequency means that once we know the value for 4 classes, we can work out the 5th. So there is one constraint, and the value of nu is 4. Note that Yates's correction only applies to contingency tables, although in this sort of situation it would in any case not be particularly useful to consider a situation with only 2 classes. Now we can work out the test statistic in the same way as we did for the contingency tables. You may like to pause the video and work this out. OK, for the bus we have 12 minus 10 squared, which is 4. Divide that by the expected value, which is 10, and we get 0.4. Here are the rest of the values for you to check. And this gives us a total for x squared of 2.68. Now we look up the critical value in the table. Remember that nu was 4, and we want there to be a 5% probability that x squared is bigger than the critical value, so that's a 95% chance that it's smaller. So the critical value is 9.488. Our test statistic is less than the critical value, so lies in the 95% section. So we do not reject the null hypothesis. And we state our conclusion in context. There is insufficient evidence at the 5% level of significance to suggest that the ratio of the vehicles using the road is different from 1 to 2 to 3 to 5 to 1. That's the end of this video introducing the chi-squared goodness of fit test. In the next video, we'll look at applying it to a theoretical distribution.